Good morning, everyone. We'll get started here in a couple more minutes. Thank you for coming and joining today. All right, it's 8 o'clock. Let's get rocking and rolling. Thanks again for tuning in today for our new topic called cold weather loop fields. Hey, want to take some notes during this webinar? You're also welcome to send us an email. Any questions or topics you'd like to hear from the future, just kindly let us know and we'll get going. I am Jim Strandlund on Technical Services today. So one of the guys in there, if you got any questions, design issues, we have a great design team as well. Give us a shout and we'll help you out with whatever we can. My email's there, jim.strandlund@intertechgeo.com. Technical Services phone numbers there as well. So welcome again. Hey, one of the greatest things is that we're hosted by Intertech University. All our webinars and our TechTime programs are recorded and put into our YouTube channel at Intertech University. We're working on getting that updated. I think we got a couple of glitches, but we're sponsored by that. And of course, Intertech Energy and Technology, Intertech USA, all the information is there as well with links to get to TechTime and our webinar trainings. So today I'd like to talk a little bit about cold loops that we've seen, especially this year. We had quite a bit of very cold weather in the northern parts of our hemisphere, and as well as the middle states, we've seen a lot colder winter than we've had for a long time. One thing cold loop fields do, obviously it does poor heating performance equals longer run times because we're trying to maintain warmth in a person's house or home. It also reduces the BTUs. As we know, colder the loop field is, the less efficient is, the less BTUs are available to provide for the homeowner. You'll also find we've heard problems with compressor noises and the harmonics associated with colder loops. The compressors run into a different envelope, may make a little bit of a different noise, which sometimes irritates the homeowners, and obviously we get some trouble calls on that way to look at. Vibration, okay, seeing where some of the vibration changes as well, part of the harmonics of the compressor. I've had refrigerant lines break, I've had electrical wires break from the vibration. So these are all problems that can be associated with our cold loop. One of the bigger things we've seen, I've been hearing more lately, is about condensation inside the pan, water running out of the cabinet onto people's floors. And I got a couple of slides here I'll show you in a second of some examples. And again, these kind of problems occur and give us nuisance fault trips. And anyway, it makes customer complaints and callbacks. So why is my thing leaking? You know, and it's a lot of people think it's the desuperheater hot water generator leaking, and typically it's a condensation or sweat occurring, which can be eliminated if things are thought and designed properly. Here's a picture of a one-year-old YT unit that you can see had some problems over this last winter, and there's actually water standing inside the base pan of the heat pump. And this water also migrated out onto the floor, which initiated a trouble call from the homeowner to the contractor, thinking they had a leak inside their heat pump or leak somewhere. Well, the desuperheater hot water generator was never hooked up on this, and when the technician went there, This is one of the pictures that he sent me and showed me. As you can see, that's our coax, and you can see the water droplets and drips on it. And this is what helped filled up the water pan and eventually ran out onto the floor. So this is sometimes mistaken as an internal water leak because of consumers seeing this on their floor. Now, the one thing you really need to remember is our modern geothermal heat pumps have a higher COP rating, the coefficient of performance. And what happens is the compressors are more energy efficient than they used to be. And so we have to rely on different run times and more BTUs coming out of the ground loop. So this is one of the issues that when you start doing a retrofit of a home, you have to think about the loop field. Obviously, we think that a replacement 5-ton has an adequate 5-ton loop field, but if you don't really know for sure, we could be in the northern hemisphere where we are 600-foot loops instead of 800s. It could be. And so the issue is if you do a like for like, the new heat pump takes more BTUs out of the ground. And when we have abnormally colder temperatures, this creates some problems. So there are some solutions that can be had, especially when you start looking at doing this retro or coming back in to repair this water condensation. Always remember that I think one of the most important things is a manual J-load calculation or some type of heat loss calc on the home to really determine if this heat pump is going to be able to handle it. The nicest or best way is adding a loop field if you think you're going to be short. But again, sometimes that can be too expensive and the homeowner may not be receptive to spending the additional money. And also, you may not know what the length of the loops are in the ground when you're replacing a heat pump because of poor documentation or really not knowing, and maybe you didn't do the install. So, but it is another good way to do it. One of the other big things we saw a lot this year in tech services was antifreeze protection. Found that this really showed up this year if you had weak antifreeze because of the freezing or slushing up of the units and flow issues, sensor warnings, etc. So again, it's imperative, even if you're doing a retrofit or replacement, what is the antifreeze protection rating? Do you know what antifreeze is in there? Sometimes that's not documented either, and it's kind of hard to know. So it's good that you have every gauge, every testing tool in your vehicle or in your possession so that you can take a small sample and check it, whether it's an alcohol-based, glycol-based, or methanol-based. You really need to know that. So I think one of the easiest ways of doing a retrofit in a situation that you really don't know what's going on is adding an electric strip heater system if there isn't one in there. When I used to go in retrofit design, that's the one thing I always looked at. I said, because I don't know the loop field, I don't know the BTU, so I'll add an extra 10 kW strip to give me 30-some thousand BTUs of additional safety. So that's probably the most economical way to make sure the homeowner consumer will have enough heat to take care of his home. You can always add a gas furnace alongside the heat pump. Some special ductwork you do helps make it going into a dual fuel, and some electrical cooperatives areas have dual fuel electric rates, so you can get by with cheaper electricity running the heat pump. They requires backdraft dampers if you put one alongside of it, or you can always make sure and do a new furnace and do a geothermal split system and do a real simple, easy conversion in that aspect. The one other thing that we've seen a lot this year is making and verifying and checking that this heat pump is working in all of its stages. That's something we have found this year, that sometimes the thermostat wasn't programmed right, or the wiring was broke off or something this year, and we never were getting into even second stage geothermal operation, as well as if it had an electric strip, we weren't seeing the electric strip come on. So the important thing is, when you do your performance checks in the fall or the spring, make sure and verify everything is working properly the way that it should. I think that was a really really important thing what we saw this year where people didn't go and double check the internal programming of your thermostats. And I think that we had a couple occasions this year too where they had electric strip heat, but it took a long time for the third stage to come on. So when a person was running low on heat for their home, we said, well, why don't you jump her from maybe Y1 over to the W call or however it is set up on your heat pump, turn that electric strip heat on faster to try to get more BTUs in there. And in turn, this also helps save the loop field. So it gives it a little bit of a chance to maybe rest a little bit more and rejuvenate itself. So marginal loops have been a real problem through this winter and a lot of other winters. So something to really pay attention and consider. Finally, one other information I would like to discuss is the thermostat in the home. Now, coming from northern climates, we start seeing issues with multi-stage thermostats with electric strip heat, right? So you would go first stage geothermal, second stage geothermal, third stage electric strip. But now as the temperature was starting to satisfy, we would see it go from third stage electric strip to second stage geothermal, first stage geothermal, and then guess what? It had to start ramping back up again. So second stage, third stage, so forth. Well, what we found is that the loop field never had a chance to rest, okay, or rejuvenate itself. So it was imperative. A lot of us went to a thermostat that would finish on the last cycle. So at the last stage of the heat pump, it would go first, second, third strip, shut down, go back to first stage or off, and then start again 1, 2, 3 over. We found that made a huge difference in some of the loop fields that were maybe marginal or extra cold weather, and give the loop field a little bit more time to rejuvenate itself and work better. So there are many different thermostats out there. Pay attention to that if that's something you like to do. Make sure it can be finished on its last stage. They have different terminology, different ways of looking at it, but there are a lot of options out there that do, and there are a lot of options out there that don't. So do yourself a favor, and if that's something that sounds good for your area or locale, check your thermostats and see how they perform in their cycling of operation. And so with that, that kind of is everything that I wanted to say today. I wanted to show you our technical services members. We are going to be getting a new gentleman here in another month or so. I'll be welcoming Kern back, and so we'll have a full complement. And again, I'd like to thank you all for attending. Our information at Intertech University is there. All our trainings recordings are recorded there on our YouTube channel. And if you have any questions, you're welcome to email the technical services at intertechgeo.com. And again, this is Jim Strandlund signing off, and thank you for your attendance today. Have a great day.